Guys, this is the part two webinar, and we will be covering all the aspects about the material and the regulations, as Nagaswari told. And we will just go through the index first. As I mentioned, this is the part two, so we will just have a quick recap on the part one. However, the same part one video you can found on the YouTube also, but we will just cover it up or to give you the base idea what we are discussing about. Next is the material which we are going to use into the lighting, and the third one is new regulations. We will again discuss on the headlights, that is the study, like the sections study and the aiming study, and little bit dig into the headlights. Same manner, we will again discuss about the tail light, how the tail light sections look like and what are the functions are there. Next is testing and validation. This is the very important point for any lighting industry. So every testing and validation, what are the type of testing, what are the validation process we are having into the lighting domain, that we will discuss. And last but not the least, the new trend, because everyone who is into the lighting, they should aware what is the trending nowadays into the market. So we will just first we will go through the recap of the part one. I'll just open up this PPT. So this is the part one. We have discussed about the basic idea what the headlights we are having on the vehicle. This is the exterior type of lighting we are discussing. As you have seen into the picture, the tail light, headlight, and the indicators are the exterior major light for the vehicle. So headlight we call as I used to see, while the tail light we are using for to be seen, and the indicators are for the directions. So these are the basic trends which we followed in earlier 90s, 1950, and now in 2050 we just went up a little bit upgrade, and nowadays DRL and sequential blinker and the projector headlamps are being used. And we are also discussed in that part one how the laser technology and the adaptive front light wing is introduced into the lighting, and many of the OEMs like BMW, Audi, they are majorly focusing on this AFS system. And we discussed about the softwares, what type of softwares are being used into the industries. Like Catia is the major software for 3D modeling purpose. So in that Catia, we do the engineering part. However, for the Class A and other analysis like CAE, light simulation, electronic circuit design, wiring harness design, rendering, and the sketching softwares are different. So majorly we are, for the engineering purpose, we are using only Catia V5 and V6 also being introduced nowadays into the OEMs. And we have covered into the part one like plastics, regulations, CAE, 3D design, 2D design, and testing validation. However, again in the part two and the current webinar, we will more dig into the testing validation and the regulation and the plastic part. And we discussed about how the typical jobs and opportunity are there into the lighting domain, and what type of pay scale you will get into the lighting. So that we've discussed, and roles for the senior levels, that also we discussed in the part one, like the design and development, handling customers issue, making them test reports, day-to-day issues, drawing, checking, release, and the shop floor issues. So if shop floor issue are majorly into the manufacturing, but if you are working in service industries, that then the shop floor issues you will be not managing. And we have also studied about the one of the case, like if we got a RFQ, then what are the process involved into the any of the dam manufacturing. So we are considering as a tier one, and we discussed about once the RFI received, then the RFQ has been brought, then the business will be awarded to any of the supplier, and then the Class A will be received from the OEM side, we will check the regulations and give the feedback to the customer. And based on the customer, the OEM will revise the surface and they will give us the back that surface, and we start designing the engineering part on the Catia. And if we like, we can go ahead to make the proto for any checking purpose or any validation purpose. Then the feedback and the model will be updated accordingly, and we will freeze the design and start making the 2D. After freezing the design and the 2D making, we start the cutting of the tool. So uh, first, feedback from the supplier, tool supplier will be received from us, and then we will finalize the design. And after the design finalization, once the part has been received, we will go ahead and do the testing, validation, and submit all the reports to the customer for the approval. And then the final production will get started. So this is how complete workflow for any of the light is there. And we discussed about how you can get into this domain. Like if you wanted to be a headlight, tail light, or into the lighting domain, then what are the major companies who are into the lighting and how you can get job over there easily. So Minda, Lomax, Valio, these are the major tier 1 suppliers who build the lighting or who manufacture the lighting, and they time to time they post some of the vacancies, so you can just go ahead and apply over there if you wanted to get into this domain. So this is all about the part 1. Now let's jump to the next part, that is the material which we are going to use into the lighting, or which are being used into the lighting. So PC, polycarbonate, PMMA, BMC, PET, PP, PP with dark field and mineral field, PVT, PVT plus PET, and milky or diffuse material. These are the major materials we are using into the lighting. However, the choosing of the material depends on the requirement. Like if, for an example, if you are making a outer lens for the headlight, then the PMMA is not a suitable material. You have to choose PC. And likewise, same if you are modeling the tail light, then the PMMA is always a recommended material, and PC is not suitable for the tail lights. While in some of the cases, it happens that for the tail light you may able to choose the PC also, but in 90 or 95% cases, PMMA is what the recommended material. In the same manner, like BMC, PET, or PC, for the reflector, if you need high temperature resistance material, then BMC is being used. But nowadays, when we are majorly focusing on the LED type of lamp, so heat generation is not more, so we can use the PC material for the reflector also. PET or PVT plus PET, this also being used into the reflector, depending on the condition of the thermal and the other space requirement. PP is majorly used where the joining process is glue, and for the hot plate or vibration welding, we are not going to choose the PP material for the housing. So if you are having a housing with the glue, then you can choose the PP. However, the PP standalone is not being used majorly. You have to use PP with the dark field or the manual field. So that will provide some strength or the stiffness to the housing, and you will be able to meet the thermal or the vibration testing requirement with the PP or PP with the dark field material. And about the 9 number material, that is the milky or diffuse material, these are nowadays majorly every OEM is using. If you see in the Hyundai cars, so Hyundai, when you majorly focus on the tail light, they are having the diffuse type of material. So while the major advantage to use the diffuse material is you will not able to see the patches of the LED or the bulb. You will get a homogeneous light output. So whenever you see the tail light or the headlight, you will see a homogeneous light, and that looks very good. So every OEM nowadays, they are using the milky and the diffuse material, and all the material suppliers also nowadays they are mixing the milky or the diffuse type of properties with the PC and PMMA also. So 9 number point is very important for the latest trend. So you should be aware that what is the milky or the diffuse material. And other selection of the material is also depend on the supplier wise or the tier one wise. They're also having some different type of material and their catalog. However, this all the nine materials are majorly used for the every OE or every tier one. Coming to the next, the new regulation. So if you are aware or not aware, just European Economic Commission of Europe. This is the major regulation agency which provides the approval on the headlights or the tail lights or any exterior light or interior light. They are providing the approval. So once the lamp it's get ready, you have to get an approval from this agency. So this agency having some of the requirements because light is a safety part. So it involves the passenger safety. Everyone has to be aware that the exterior lighting or the interior lighting majorly plays a role for the safety also. That is why we are having some certain regulation. So in this regulation, majorly they mention how much light output is required, how much angle the light should go, and what are the criteria to get this homologation approval. So previously for the each function, so in the function I already explained into the part one, so you can just go over there and check it out. So in the function we talk about the indicator, the high beam, low beam, reverse function, tail stop functions. These are the functions where each of the function having different regulation. So this was the older one, and for the number plate lamp we are having, previously we were having the in the same manner we were having the R3 and R6, R7. These are the regulations which are applicable on the functions wise. So we already covered that into the part one, and now all the release has been removed and they are only having these three regulation nowadays. That is the R148, R149, R150. So R148 is the approval of the lighting devices, signaling devices basically. So all the signaling devices like the tail function, stop function, or the this one turn indicator, these are the signal devices. They are giving these signals to the end use end user. I mean the vehicle which is coming from the back side or the having on the front side. This driver gives the signal that I'm turning, I'm stopping. This type of signal they are giving. So all the approval for the signaling devices comes into the R148. So they have released a new version in the R148. You can download this file from their website and you can check it out thoroughly that what are the signaling devices approval requirements are there. In the same manner, in R149, we are having the headlamps illuminating devices for the all the headlights, all the light which is coming on the front side for the headlamp, that is the low beam, high beam, and DRL. This comes into the R149. While the R150 is basically giving you the markings approval. Like every lamp is having the approval marking. So everyone should aware that on which year this lamp get homologated. So after the getting the homologation, this agency give you a certificate or the number which you have to print on the lamp. So R150 is basically all about the markings. So what type of marking you should place on the headlight, tail light, and what are the criteria? How much height it should be there, how much length it should be there. And nowadays they are also involved the QR scanner. So it's very easy, but in India, we all the tier one is not adapted but many of the tier one are installing that devices, and they are printing the QR scanner. So that can be print the QR code on the headlight or tail light. So everyone should aware by the scanning that which are the details, which are the functions, which are the year of the manufacturing is there. So this new regulation has been involved, and the reason of the changing this regulation from each of the function to a complete bunch is whenever they have or they got some feedback, uh, they release a new update on the regulation. Like if they got a feedback on the turn signal, so they have to update the R4. And if they got an update for the tail light or feedback on the tail function or the stop function, they have to update the R7, R28 accordingly. So these are very time consuming, and every day they are releasing amendment on their release. So now they only have to update only one file. Like if they got a feedback on the turn signal, so they only have to update 148. They do not have to update the tail function, complete tail function release. So this is very helpful for them also, and this is very helpful for the agencies also who are involving this regulation approval. And for the tier one and the OEM also, this is very easy. So they only have to check whether the R148 is having a new amendment or not, and the same for the R149, R150 or not. Let me check if I have this file, so we can just quickly go ahead and check R148. Okay. So this is how the file looks like, and you can go ahead. There are 58 pages. You can just check out whether what are the index and what type of scope they have. They mention each and everything very clearly, and you can go ahead and check out what are the criteria for the front side indicator, or like this is the signal devices. So like the front direction indicator, how it should be installed, and what type of the symbol they are going to use. Like for the front direction indicator, which is having the distance only 20 from the passing beam or the low beam, we can call it, or the front fog lamp. If the front fog lamp is not there, then the passing low beam is applicable. And if the passing low beam is not there, then the front fog is applicable. So that comes under 1A category. So this is the symbol you can use, 1 and the small a. And same way, if we are having front distance from the passing beam or the low beam or the front fog, then 40 then one category is applicable. And in between is the lamp is there, then the 1B category is there. So this is how they have defined each of the category. There are multiple categories. You can go ahead and choose what type of category you are having or you are designing. While designing, many of the OEMs already mentioned that my lamp is coming under 1A category or 1B category or 1 category, and accordingly you have to design their light. And 1 second. And 1A category, basically, if we talk about the difference between 1A, 1B, and 1, so there are a different requirement of the output. Like for the 1A category, the 400 candela is required. 1B category is 800 candela is required. So like that, the numbers you can check it here. I'm not completely 100% sure that 400 or 800, but I just mentioned that what type of difference is there. So if you're having a indicator near to the fog light, then the higher candela is required, because that should be visible. And if you are having the turn indicator far from the front fog or the low beam, then the lower candela is sufficient. So this is how the symbols work. And you can just go ahead and check out the entire document. This is completely free of cost, available on the website. So on the EC, you can search Economic Commission of Europe, and over there you will just go and check the regulation for the lighting. So and you can download all the R148, 149, and 150, and you can just go ahead and check out the details. So here is there. The requirement is there. So in the 1B category, 400 candela is the minimum intensity. In the 1A category, 250, and the 1 category, 175 candela is required. So as I mentioned, in the 1 category, we already checked that 40 mm distance is comes under the 1 category. Like if you are having more than 40 or 40 mm distance from the low beam and the or from the front core, then 150 candela is the requirement. And likewise, in the 1B, it is the lowest or nearest category. So this is having the higher candela requirement. So this is the only difference is there. And for the all categories, they have mentioned each detail, and you can go ahead and dig into it. What are the details they have mentioned? And the installation wise also, they have mentioned each and every detail in this document. So this is just, I have given an overview how you can check the R148, and the same in R149 and R150 is there. So in R150, you can see that the marking details is mentioned, what type of height and what type of depth you have to plot, or what marking or unique identifier should be there. So if you are considering 1 is equal to 8 mm, then A by 2 should be for the UI, and this type of symbol and this type of number, this is a certification number. So once your lamp get homologated, you will get this type of number. This should be print on the light, I mean on the housing or the visible area. So either you are making the headlight or the tail light or the indicator, side indicator, number plate lamp, this type of number should be there, and this comes A by 3. So this type of detail you can find on the 150. And let's go to the 149 also. In the 149, they have mentioned the headlight, front side headlight details, and that comes under this regulation, like high beam, driving beam, or the high beam. We can say the passing beam for the asymmetrical and the symmetrical, and what are the symbols is applicable. So in the same manner, you can check this document also. And this is having 133 pages, so it will take time, but it is very important for you, for all the designer of the light. They should be aware of this document, where and they have to check the amendment also time to time, what are the changes they are making. And now they have changed from each function to combined functions, like this we discussed. So it is being very easy to understand what they are trying to say and what we have to keep in mind while designing the lights. Coming to the next, that is the headlight section. So here we are having one of the model which is being in design, and we just talk about the function first. So we are having the WY16W, that is for the turn indicator, and we are having H11, that is for the high beam, and HB3 for the low beam, and also we are having the W5W for the position. So, and you can see that there is a 2 or 3 sections are there. This is basically is being used for the aiming purpose. Like if the vehicle is running on the hilling area or any slope area, then the headlight, if you are not rotating the headlight, then the focus of the light will not float on the road. It will go on the above the road. So to maintain that the light should go on the road and it will be visible for the to the driver, then aiming is required. So if you might have drive any of the vehicle, you can see on the steering side there is one rotation button is there, which you can use to rotate the light, front side light, that for the high beam or the low beam. So that allows you or the driver to shift the light focus. And this is what you can see over here. This is being rotated by the driver, and this allows the light should go on the roadside, not on the up of the road. So if you are on the hill area or on the slope area or even on the normal plain road, you can shift or adjust the light according to the your condition. So you might have noticed that on the steering side, on the right hand side, you can see a rotation button where 1, 2, 3, 4 is mentioned. So that is used for this purpose only. So we talk about the aiming and the bulbs and the function, and the talk about already talked about the material. So this material is PP with the dark field, and this reflector material, it could be PC or BMC. Like in the H1, the heat generation is more, so we can check with the thermal simulation where the heat, what type of what is the maximum temperature we are getting with this bulb. Like if we are getting 145 degrees centigrade and our PC is having the HDT of 135 degrees centigrade only, so we have to change the material. We can either choose the PVT and PET also. It depends how much heat is being generated by this bulb. So in the WY16W case, what I remember is the heat generation is not very much. It will go only up to around 95 or 100 degrees centigrade. But that again depending on the condition. Like if the volume is more, then the heat generation is less. And if we are making a very compact design, then the heat generation is higher. So if we are having the STT or the thermal of this bulb is only 100 or 110, then we can go ahead and choose the PC for this reflector. And we are having a standard lens for the headlight. As we already discussed, that the PC is being used, and the this part, this is the bulb. So if there is a standard bulbs are there for any OEM. The suppliers are there like the Osram, Philips. These are the supplier of this bulb. So you can choose from that, and they are having the standards library. So you can just download that bulb and install it into the headlamp. And the W5W also, this is very standard feature. And if you see this pivot is there, so this is a BOP part we can purchase from the supplier, or even we can design it our own depending on the aiming condition requirement. So this part we majorly having the PS6 material, that is the nylon material, because it should be strengthened enough to withstand the reflector load, and it should hold the reflector also. So if we go with the PC, then the stiffness is very low. So we have to choose the right material, that is the higher stiffness, and we can go ahead and choose the nylon material for this. So this is the all about the basic section of the headlamp. However, there are many other BOP parts involved into the headlight, like the dust cap is there, the aiming bolt is there, which help to rotate the reflector manually, and many other parts, wire harness, and sometimes you have to use the desiccant bag, the vent cap, the Goya patch. These are the basic requirement of the headlamp. There are almost 40 to 45 BOP parts, small or major parts, which being used into the headlights. So we are not having sufficient time to cover that all the up. However, the basic section, which is very important for the session 2 that we are discussing here. Now coming to the section of the tail light, the same manner we are having the standard bulbs, which you can download from the standard suppliers like Osram and Philips. And this is the P21/5 port. This is dual function bulb, which gives you the tail output and the stock output both. And we are having the W5W, that is the position, and we are having the PY21, that is the pin type yellowish 21 watt bulb. So this being used for the turn indication requirement. So for the housing, we are having the PP material, which if we are going with the glue or if we are going with the vibration, then the ABS material is also being used for the housing. And as we discussed earlier, for the lens, we are having the PMMA material, and this is the standard bulb. Here on the tail light, we are not having major BOP parts. However, only general parts are there. Almost maximum max to max 10 to 12 parts are being used for the any bulb type lamp. But on the LED type, it depends. We are having the driver PCB or single PCB. But for the bulb type, we are only having the 10 to 12 maximum components, like this vent cap is there. So there are multiple parts which also being used into the tail lights. We can also use the desiccant bag, which absorb the moisture from the lamp. This also depends on how much moisture or the condensation is being seen by the simulations into the tail light. And sometimes we use the heat shield also to protect the heat to make the reflectors. And we also sometimes we use the reflector as a separate part. Like here, we are having the separate reflector, and this can be a PC material because the heat generation in the taillight is very low. But again, you have to simulate in the software how much heat is getting generated by this bulb, and depending on the heat requirement or the chamber requirement, you have to select the material. And if you are having a very limited space and also constraint of the material, like you only have to go with the PC, then the heat shield can be used over here. So this is how the tail light section works. And bulb, as we discussed, this is the standard part. You can download as a standard library from the Osam and the Philips. Now coming to our next topic, that is the testing and validation. This is a really important topic, and every OEM after manufacturing, they have to check all this. There are many testing and validations, but I have covered this 9 point only, which are the applicable as a designer also, and other testing and validation is a part of responsibility of the lab. But if you are involving in those activity also, that will be helpful for you only. But as a designer or as a design and an initial stage, you should be keep in mind that this 9 point, keeping this 9 point in your mind, that these are the basic requirement, and you have to, yes, it is your responsibility to fulfill this requirement. So first is gap and flush. So if you might have seen in the Hyundai's car or the Tata car, the major difference what you can see is in the Tata car, they are having the much gaps between the lamp and the BIW or the body in white. So you can see the inside part very easily. But in the Hyundai car, they are very, very they're focusing on this gap and flash requirement, and they are very having they are keeping it very low, like 0.5 mm or 0.7 mm. While the Tata is also having the same requirement, but you might have seen sometimes that the gap is more or the flush is more in the Tata car, or it depends on the over period of time. The lamp is getting warped, or due to heat condition, um, their stiffness is low and they are getting warped. So you can see the gap is more, and it is flush is more at the installation. So as a designer, you should keep in mind that what are the requirements has been given by the OEM. You should fulfill it. What you can do to overcome this issue or to check how much gap is there, there is two ways. One is tolerance is stack-up analysis. So you can, while the designing of the mounting points, you should check the gap and flush with the tolerance stack-up. How much tolerance you are keeping on the mountings, like 0.05 or 0.5 mm, or what type of tolerance you are giving, what type of profile tolerance you are giving on the lens. So this comes under the GT&T. This is the mechanical part. And the simulation part, what you can do, you can go ahead and check the mode flow of the part once the design is ready. So in the mode flow, you can see how much warpage is coming in your part and how much gap is coming with your part. In the X, Y, Z, all the three direction, it will give you an idea how much warpage is there. So according to the warpage, you can give the more strength to your part, or you can get an idea that this is the warpage is coming, and accordingly you can modify your tolerances. So these are the two ways to overcome this issue. The second is the leakage testing. In the leakage testing, what they check after the locking of the lens and housing, like in the glue, we will create the glue, or in the vibration, we just vibrate the lens and housing and we just lock it, or in the hot plate, we just made the material and lock it. So after the locking, is there any leakage of the air or the water? So what we do, we just uh, we just wide or lock the lens and housing, and after putting all the parts at certain area, we apply some air pressure, and by the air pressure we can check whether this leakage is happening or not. So while the pressure is giving or the air is dropping inside the lamp, if you find any bubble or any leakage, um, you can find out that leakage is happening or not. So this is a compulsory requirement. So all the lamp has to be checked properly with this leakage testing. And on the line itself, we sometimes we provide the leakage testing machine. So every operator check all the parts whether the leakage is happening or not. Because in the on the road condition, if the leakage is there, then the water can go inside the lamp, and that is very dangerous. That will lead to a failure of the light function. Third one is thermal. So we already talked in the section part. The thermal requirement is there, and that depends on the requirement of the space what you are having, and type of bulb what you are using. Like in the LED cases, the heat generation is not more. However, in the bulb segment, the heat generation by the bulb is very much high. So you have to check it. In the design stage only, you have to do the simulation. And there are certain benchmarks already also available with the all the tier one companies, and they are having or they are choosing the material based on that their benchmark only. But it's always recommended to go with the simulation after designing your lamp. The fourth one is the photometry, and this is the very essential and the crucial part, because the regulation what we discussed, it uh, check the photometry of your lamp, and your requirement should be fulfilled, right? Like if we are having the 1A category of the front side lamp of the indicator, then it should meet the 400 candela, and it should be not more than the 1200 candela. So that type of requirement, this photometry can check, and it will give you an idea. While the simulation, with this simulation also, you can check how much output is coming in your lamp, and accordingly you can modify your optics, you can modify your light source, or you can, if you're in the LED case, you can change the binning also. So this is how the photometry validation is compulsory. The fifth number is the vibration. Every OEM is having certain vibration requirement, like the 66 or 56 hertz is there, depending on their condition. So why it is important? Because on the road, we know in the Indian roads, the vehicles, we are not having very keen roads. So vibration is possible in the light also. So with that vibration, is it possible that the light source will have will lose its intensity, or is it possible that with the vibration the light source will fail? So that will lead to a failure also, and that is why it is very important to check whether the hertz requirement whatever they are giving, and that hertz the lamp is not getting frayed, or it is not getting warped, or the failure of the focal point of the light source is also not happening. So you can check with the vibration simulation. There is a software of the ANSYS. You can check into that, and this is also help you to identify your gap and flash requirement, because in the vibration you can check your mounting points. You have to provide the mounting point as an input, and then they will tell you that after the vibration how much work which is coming. So that will also help you to identify the gap and flash requirement. Coming to the sixth number, that is the electric current. That is majorly for the electronic circuit only. While if we are having the bulb, then the electric current is very easy to identify. It's just the wiring harness, and the 12 volt or the 13.5 volt is there from the vehicle side. So you just go ahead and check the bulb spec, how much voltage is required for illuminating that bulb, and it is very easy. But in the electronic circuit, you have to check all the condition EMI, EMC test it is there. So you have to check all the electronic current, and that also being done into the software also. So you it's always recommended to do it on design stage. The seventh number is the condensation. So in the mm, winters, you might have seen that the fogging is taking place inside the lamp. If you might have noticed that the fogging, sometimes the headlamp is having the fogging condition, and that is called as a condensation. That is majorly happening due to the weather change, where the heat is in the inside lamp is heat is higher, and the environment temperature is lower. Then the condensation takes place. So condensation takes place, and this should not happen as a standard. And for that reason, we are having the anti-fog coating also on the lens, and sometimes we are using the desiccant bag also to eliminate this issue. However, there is a condensation simulation also, so you can identify that condensation simulation whether this scenario is happening in your lamp or not. Now the eighth number is the material testing. So this is a standard, and all the material supplier gives you the report that it is ALV compliance or not, it is biodegradable or not. This type of requirement is there. So the material supplier will do the testing and give you the report. However, as a OEM or as a tier one, it is also your responsibility to check whether the material testing has been done or not. Or time to time, it has to be repeat. So this is also very important part. The last but not the least, the homologation. So as I mentioned, all the agencies are following the EC and the AIS regulation, and they will give you the homologation certificate. In the homologation certificate, what they check, they will check the photometry requirement. And once the photometry requirement is getting fulfilled, you will get a certification, and that certification number you have to print on the visible area of the lamp. So if you are having the headlight, then the outer lens, it should be print or it should be visible once the bonnet is open. So sometimes you have to place on the top side of the lamp, or in every condition or every function or every exterior lighting, the homologation number should come. So once you get the certificate, you have to engrave on the lamp. So this is a very general idea. However, there are multiple or more than 25 testing or validation requirement is there, or depending on the OEM condition. Sometimes it's more than 25 also. Sometimes it's less from 25. But major as a designer, you should keep all these 9 in your mind, and rest of the testing can be done by the lab. Now coming to the new trends of the lighting. So as we are having the laser light as a new trend. So i8 and R8, that is the BMW vehicle. So they are majorly introduced this laser light system, and Osram is having the same source, and they are providing the laser system to the BMW. And nowadays, every OEM also started to incorporate this new trend, and they are shifting from LED to the laser light. Coming to the bending technology, in the part one also we have covered this up. So this is very unique feature or the adaptive system of the light. So this is called as an advanced front forward light system. So it turns automatically when the road is getting bent, and you do not have to do anything. It will also reduce the focus once the passenger is in front of the lamp, so they will not get a glare of the light. And if any vehicle are coming from the front side, it will reduce the light on that vehicle, and it will give you the sufficient light to the driver. So this is a very new technology, and all the OEMs also being started using this, but it will take time for the India to introduce this type of light system. We are majorly, as a India, we are majorly focusing on the laser light system, but this is definitely in the roadmap of the every OEM. If we talk about the tail light, then the OLED is the majorly new technology which every OEM is getting introduced. So we are shifted from the bulb type to the milky lens or the diffuse lens, but now we are shifting to the OLED also. So this is also being introduced by the BMW, and the major support is been given by the OSRAM to the OLED system. So this is also a very unique technology we are introducing. So if you might have seen the OLED, nowadays we are having into the our LED, and the televisions. So we are having the OLED screens on the mobile. Also, we are having the OLED screens, and the same manner we are introducing the OLED screen on the tail lights. So this is all the things we covered up into the part two.